Greetings everyone, welcome to E&E Learning Hub. I'm going to go through question 1 from the 2022 CSEC Electrical and Electronic Pass paper. I already have the solutions in place, so I'm just going to go through and explain everything that I have there. Going forward, this is how I'm going to approach each past paper question. All right, so let's begin. Part 1 of A. It says, state the two basic rules governing electrical charges. 1, like charges repel. 2, unlike charges attract. So those are the two basic rules governing electrical charges. Part 2 of A. It says, sketch a shape and direction of the magnetic fields that exist between the ends of two bar magnets if the magnet poles are identical to each other and opposite to each other. So let's look at the first one. We're going to have two bar magnets with the poles identical to each other. So as you can see here, for the magnetic field, it is going outwards as indicated by the arrow. Let's move on to the second one. So here we have two bar magnets with poles opposite to each other. Now for the magnetic field, it is going from north to south as indicated by the arrow as well. Also note that magnetic fields, as I mentioned before, it goes from north to south. All right. So that's it for part 2 of A. Let's move on to part B. So it says two wire wound resistors R1 and R2 with equal ohmic resistance are placed in parallel across a 20-volt DC source. A total current of 2 amps is flowing in the circuit. Part 1 of B, it says sketch and label the circuit configuration. So I already have the circuit configuration in place where I have R1 and R2 connected in parallel across a 20-volt source, and we have the total current of 2 amp flowing in the circuit. So that's it for part 1 of B. Let's move on to part 2. It says determine the ohmic resistance value of the fixed resistor R1. So let's look back at the circuit. So for part 2, it is asking us to determine the value for R1 here. Let's go back to part B as well. Now, what is important to us where part B is concerned, it tells us that both resistor value, they are the same. Now, as it relates to a parallel circuit, when you have two resistors connected in parallel and they are of the same value, the current is shared between them equally. So it means that in order to calculate the value for R1, we'll have to first calculate the current that is flowing through R1. All right, so let's scroll down. So the current flowing through R1, so IR1 is equal to IT divided by Rn, which is the number of resistors. That is 2 amp divided by 2, and that will give you 1 amp. And that will give you the current that is flowing through R1. Now, because both resistors have the same value, current will share between them equally, as I mentioned before. So if 1 amp is flowing through R1, it also means that 1 amp is flowing through R2 because the current is shared equally. So now we can look at the calculation for resistor R1. R1 is equal to V1 divided by I1. Now remember that it's a parallel circuit, so it means that the voltage is constant, or it is the same. So it means that R2 will have the same voltage across it as a voltage source, and also R1 will have the same voltage across it as the voltage source. Hence, R1 is equal to 20 volt divided by 1 amp, and that will give us 20 ohm. So that's it for part 2. For part 3 now, it says determine the maximum power that is dissipated across each resistor. So P max is equal to I times V, that is 2 amp multiplied by 20 volt, and that will give us 40 watt. So this will be the maximum power that will be dissipated across each resistor. So let's move on to part C. So it says, with the aid of neatly labeled sketches, show how a multimeter should be connected to a resistive circuit to safely measure each of the following quantities. Note, be sure to indicate clearly the polarity and the power requirements where applicable for each connection. Part 1 of C, DC voltage drop of a resistor. All right, so here I have the circuit in place already, and the meter is connected in parallel with the resistor to measure the voltage across it. So this is how it is done. So whether it's a parallel circuit or a series circuit, the meter will be connected in parallel with the resistor to measure the voltage drop. Also, as you can see as well, the polarities are there. All right, so that's it for part 1 of C. For part 2, it says total DC current in a circuit. Now, for this circuit, I have the meter connected before the source, so that way it will be able to measure the total current flowing from the source through the circuit. Also, the polarities are there. All right, so that's it for part 2 of C. So for part 3 now, it says resistance of a resistor. All right, so to measure the resistor value of a resistor, the meter is connected in parallel with the resistor, or it is connected across the resistor. So that's it for this question.